Good morning, everyone. Today we discuss the next sorting technique, bubble sort. Bubble sort works like the bubble in the water. So all of you aware about the bubble in the water. So why this sorting is called as the bubble sort? Because the first element, see, this is one of the example. This is the one of the array which consists of the five different elements. The first element is 5. So at the first pass, the first element take the final position in the given array, and that's why it comes like the bubble in a water, and that's why it is called as bubble sort. See, at the end of first step, this 5 gets the proper position. Proper position means the first is 1, at second position 2, at third position 4, first, second, then 4, and at fourth position 5. Means this first element takes the proper position. It's a final position at the end of pass 1, like the bubble comes in water, and that's why it is called as the bubble sort. Okay, so this is the data given to you. This is one of the array, data array. This data array consists of the total 5 elements. See, these are the positions 1, 2, 3, 4, and then 5. Okay, the 5 elements are given. Now, what happens in case of the bubble sort? In case of the bubble sort, first of all, the first element is compared with the second element. If the first element is greater, then first and second both both values will get exchanged. Here, the first value is greater than the second, so that's why the first two values will get interchanged. Now, the remaining data is as same as it is. Then the second value is compared with third value. If the second value is greater than the third value, then again exchange the data. So 1, 4, 5, the remainings are similar. Now the next third element is compared with the 4. Once again, the third element is greater than the next element, then exchange the data, swap the data. 1, 4, 2 here, and 5 is at the location previous data element location 2, and the last element is 8. Now this 5 is compared with the 8. This 5 is greater than 8? No. This first element is greater than second element, then interchange the values or swap the values. But here 5 is not greater than 8, and that's why here is no swapping, here is no interchanging of data, and that's why data is as it is. So finally, then what happens at the end of this is your pass 1. So at the end of this pass 1, you will get the final position of 5 into the array, and that's why it is called as a bubble sort. Why it gets the final position? See, if you see at the left side of this 5, left side of this 5, all the elements are small than the 5, and the elements at the right of 5 are the greater elements. Means the first element 5 get the final position. It occupies the final position like the bubble in water, and that's why the name is given as a bubble sort. Still, the elements are not sorted here 1, 4, 2, because 2 is at second position and the 4 is at third position in the final output. So once again, the second pass will be applied here. At the second pass, the first element is 4. This is compared with first element is compared with second element. The first element is not greater than second, that's why there is no swapping. Then 4 is compared with 2. Yes, the 4 is greater than the 2, therefore there is a swapping. So 1, 2, 4, then 5 and 8 as it is, and hence this is the final output. So like this way the bubble sort works. Now we will see the actual algorithm of the bubble sort, then the tracing of the algorithm with this same data. Okay, so now we discuss the algorithm. So what is the algorithm? See, this is the name of algorithm is bubble. It requires the two parameters. The first is the array and the second is the number of elements in the array. The data is the array and n means the number of elements. Okay, so this is a data. This is a data array given to you and n means 1, 2, 3, 4 and 5. Means the total number of elements in a particular array. First step, right? See here, repeat step 2 and 3 means you have to repeat the step 2 and 3 for the pass k equal to 1 to n minus 1. Okay, so initially k equal to 1 means the k is at the location 1. The k is at the first location. Okay, now the second, set ptr equal to 1. So where is 1? This is the 1. And now once again the PTR is here. This is PTR and this is K. Initialize pass pointer. Pass pointer initialize means what? Every time you have to just pass the pointer from first to second, second to third, third to fourth, fourth to fifth, because you have to compare each and every element with the other elements. So to pass the pointer, you have to initialize first it with the value 1. So PTR equal to 1. Repeat while PTR is less than or equal to n minus k. What is the value of PTR here? The value of PTR is 1. So 1 is less than or equal to n. What is the value of n? The value of n is 5 minus k. What is the value of k? 1. So 1 is less than or equal to 4. You have to directly go for the loop and check 1 is less than or equal to 4. Yes, the condition is true. If the condition is true, then control enters into the loop and checks whether the data of PTR is greater than data of PTR plus 1. What is the value of data of PTR? The data of PTR value is 5. And you have to check whether this data of PTR is greater than data of PTR plus 1. PTR equal to 1 value. PTR plus 1 means 1 plus 1, that is equal to 2. You have to compare the first element with the second element. How? See here, the step data of PTR is greater than data of PTR plus 1. The value of PTR is 1, 1 plus 1, that is equal to 2. So data of 2, you have to compare. Okay, the condition is true. 5 is greater than 1. So what is the solution? The solution is you have to interchange data of PTR and data of PTR plus 1. Interchange means you just keep the 1 at the first location and 5 at the second location. Okay, so how? So I directly write down here. PTR means 1. 1 is less than or equal to 4. The condition is true. Then you just exchange the values. So 1 here, then 5, then remaining element as it is. Once again give the positions 1, 2, 3, 4, 5. Okay. Then the second step is PTR equal to PTR plus 1. Now you pass the pointer, you move the pointer to the next position. You move the pointer to the next element by increasing pointer plus 1. 1 plus 1, 2. So this PTR will get collapsed and the new PTR position is at the second location. Okay. Now while PTR is less than or equal to n minus k, PTR is less than, so now the PTR value is 2. 2 is less than or equal to n minus k. N means 5. Then 5 minus 1, 4. So at first pass, you have the value is 4. Now you have to check data of PTR. Data of PTR is greater than data of PTR plus 1. What is the value of data of PTR? Where is the PTR? See here. PTR equal to PTR plus 1 means your PTR is now at second location. Okay, at second location. So you have to check whether the data of PTR, the value of data of PTR is 5, is greater than data of PTR plus 1. 2 plus 1 means 3. Yes, again the 5 is greater than 4. So just you have to exchange the both values. So 1 here 4 and at the place of 4 here 5, then 2 and then 8. 1, 2, 3, 4 and then 5. Okay. Now set PTR equal to PTR plus 1. So this PTR will get vanished and The new position is 2 plus 1, that is equal to 3. Your new PTR is at third location. Again, you have to compare. Again, the control goes back to the loop. Compare PTR is less than or equal to n minus k. Now the value of PTR is 3. So 3 is less than or equal to 4. Yes, condition is true. So it enters into the loop. Data of PTR is greater than data of PTR plus 1. Data of PTR is 5. PTR plus 1. 3 plus 1, that is equal to 4. 5 is greater than 2. Yes, condition is true. If the condition is true, then just you have to exchange the both values 5 and 2. So 1, 4, then here 2, and here 5, and then 8. 1, 2, 3, 4, and then 5. Now, set PTR equal to PTR plus 1. What is the value of PTR? Previously 3. So this old PTR will get vanished and the new value is set at the location 4. Again, your control goes back to the loop. While PTR is less than or equal to n minus k. Now what is the value of PTR? 4. So 4 is less than or equal to 4. Condition is still true. Why the condition is still true? Because is less than or equal to 4 is equal to 4, and that's why the condition is true. Again, it enters into the loop. Check data of PTR is greater than data of PTR plus 1. So data of PTR is 5 is greater than 8. No, the condition becomes false, and here the inner loop ends. Inner loop ends. Now you go to the outer loop. The control is directly jumps to the outer loop, and here the value of k is increased by 1. Initially the value of k is 1. This is the end of pass 1, and see here at the end of pass 1, the first element 5 gets the final position in the array. How? Because you see that at the left of this 5, 1, 4, 2, all the values are small than the 5, and at the right the values are greater. So this is the end of pass 1, and this 5 comes like the bubble in the water. It occupies its final position at the pass of at the end of pass 1, and that's why it is called as the bubble sort. Now the same steps will be repeated for the next pass. The next pass is k equal to 2. So see here, this is the another comparison. See here, at the pass 1, how many comparisons you require? 1, then 2, then 3, and then 4. You have the total elements 5, means n. In the first pass, you will require the n minus 1 comparison. 5 minus 1, that is 4. 1, 2, 3, and 4. And then finally, your first element will be placed at the final position. So now the second pass. At the second pass, what happens? The that k will be updated to the next position, because this is the second pass. So k equal to 2. Your k is at second position. Okay. Now again evaluate PTR equal to 1, means your PTR is at the first position. Okay. Now repeat while PTR is less than or equal to n minus k. Repeat while PTR is less than n minus k. What is the value of PTR? PTR, the value is 1. So 1 is less than or equal to n. The value of n is 5. 5 minus, what is the value of k now? 2. Because this is the second pass. So 5 minus 2, that is 1 is less than or equal to 3. Yes, the condition is true because 1 is less than 3. So it enters into the loop. Data of PTR is greater than data of PTR plus 1. What is the value of data of PTR? The data of PTR is 5. Now you have to check 1 is less than or equal to 3. Data of PTR is 5. 5 is just 1 minute. What is the position? the position of the end of pass 1, actually the pass 1 positions are 1, 4, 2, 5, 8, 1, 4, 2, 5, 8. So you just apply the steps at the updated data on the updated data. So this is the final step that you will get in the pass 1. So this is 1, 2, 3, 4, and then 5. This is your K, and here is the PTR. Okay. So data of PTR is greater than data of PTR plus 1. What is the value of data of PTR? The value of data of PTR is 1. And what is the PTR plus 1? 4. So 1 is greater than 4? No. So there is no change. So there is no swapping. 1, 4, 2, 5, 8. Why? Because this 1 and 4 are already in a sorted order. So positions 1, 2, 3, 4, and then 5. Now set PTR equal to PTR plus 1. So this PTR will get vanished, and this PTR plus 1, 1 plus 1, 2. So PTR is at second location, and K is also at second location. Again it goes to the loop. Check again. PTR is less than or equal to n minus K. Now the value of PTR is 2. 2 is less than or equal to 3. Yes, the condition is true. So once again you check data of PTR is greater than data of PTR plus 1. Yes, 4 is greater than 2. And here you swap the values because data of PTR is greater, means data of first element is greater than the second element. In this case, we have to swap the data. In this case, we have to interchange the data. So what will be the output here? 1, then 2, here 1, 2, 4, 5, and 8 as it is. 1, 2, 3, 4, and then 5. Then set PTR equal to PTR plus 1. The PTR is at second location. Now the new PTR is at third location. 2 plus 1, that is equal to 3. And your K is at second, because this is your second pass. Again it checks. PTR is now 3. So 3 is less than or equal to 3. Yes. 3 is less than or equal to 3. Yes, because 3 is equal to 3. That's why the condition is true, and it executes the loop. If data of PTR is greater than data of PTR plus 1, data of PTR is 4. So 4 is greater than 5. No. Here the condition becomes false. If the condition becomes false, then what happens? Then there is no interchange. The data is as it is. So 1, 2, 4, 5, and then 8. 1, 2, 3, 4, 5. Now PTR equal to PTR plus 1. What is the value of PTR previously? 3. So 3 plus 1, that is 4. So the new pointer is at location PTR. Now your control goes back to the loop. PTR, what is the value of PTR? 4. 4 is less than, here 4 is less than or equal to 3. The condition becomes false. The 4 is not less than. So here end of outer loop, inner loop as well as the outer loop. See, in the second pass you require 1, 2, and then 3 comparisons. 1, 2, and 3 comparisons. In first pass you require the 4 comparisons. Means in the first pass you require n minus 1 comparison. In second pass you require n minus 2. N are 5. 5 minus 2 means 3. See, 1, 2, and 3. So you require 3 comparison. Because for the calculation of complexity of bubble sort, you must know how many comparisons are required for each pass. For pass 1, pass 2, up to the pass n minus 1 and pass n. Okay. Now all these elements are in a sorted order. 1, 2, 4, 5, 8. But still your algorithm is not completed. So that's why again you have to evaluate this algorithm for the next pass. The next pass is what? The next pass is K equal to 3. 1 to n minus 1 means 1 to 4. Now the next pass is 3 means what is the output? 1, 2, 4, 5, 8. So here I write the output of second pass, that is 1, 2, 4, 5, 8. 1, 2, 3, 4, 5. Okay. Now at the third pass, your K is at third position. At the third pass, your K is at third position. PTR is initialized at first location. Initially, the first element is compared with second element according to your algorithm. PTR is greater than PTR plus 1. No, the one is not greater than 2. Hence, there is no swapping. The data is as it is 1, 2, 3, 4, and then 5. Again, then PTR equal to PTR plus 1 means this PTR will get collapsed, and now the PTR is at second location. Now you have to compare the second with the third. Then again, the 2 is not greater than 3. 2 is greater than 3. No, condition false. So again there is no swapping. So data as it is 1, 2, 3, 4, and then 5. Now control goes back. Now you check here PTR. Sorry, PTR equal to PTR plus 1. The previous PTR is at the second location. Now PTR is at the, just 1 minute. These are actually the positions. So the actual data is this. So 1, 2, 4, 5, 8. 1, 2, 3, 4, and then 5. Now at second pass, you have the PTR. Then you compare 2 with 4. Again, the 2 is not greater than 4. So there is no change. So data as it is 1, 2, 4, 5, 8. Now the pass is third. Now PTR will get vanished. PTR equal to PTR plus 1. So your PTR is now at fourth location. 1, 2, 3, 4, and then 5. Now compare 4 with 5. Again, 4 is not greater than 5. So there is no swapping. So you will get 1, 2, 4, 5, and then 8. Now PTR equal to PTR plus 1. So 3 plus 1, 4. Now your PTR is at this location. And now you check PTR is less than n minus k. PTR is less than. PTR means your PTR is at the fourth location. So 4 is less than n minus k. N means 5 and k means 5 minus 3. That is equal to 5 minus 3, that is equal to 2. 4 is less than or equal to 2? No. Here the third pass ends. So now the last pass, fourth pass, because we require the n minus 1 pass, we have the total 5 elements. So 5 minus 1 means the 4. We require the 4 passes. So once again, your k is at the fourth position. This is 1, 2, 3, 4, and then 5. Your k is now at fourth position. Then set PTR equal to 1. Set PTR equal to 1. While PTR is less than or equal to n minus k, what is the value of PTR? PTR value is 1. Is less than or equal to n minus k. What is n? 5. 5. What is the value of k? 4. So 1 is less than or equal to 1. 5 minus 4, that is equal to 1. Means this n minus 1 pass executed only for the one comparison. Okay. Only one time. So the case is, this 1 is less than or equal to 1. This is a true. So it checks data of PTR. Initially your PTR is at first location. Data of PTR means 1 is greater than data of PTR plus 1 means it is a 2. Yes. Again, 1 is greater than 2. Condition is false. If the condition becomes false, then there is no change. Means 1, 2, 4, 5, 8 as it is, and these are the positions. Okay. Now set PTR equal to PTR plus 1. This PTR previously is at location 1. Now your new PTR is at the location 2. Then you just check whether the PTR is less than or equal to n minus k. The PTR, the value of PTR is what? Value of PTR is, now value of PTR is 2, and that is less than or equal to n minus k. 5 minus 3. 5 minus 3. 1 is less than or equal to 1. Okay. No, sorry. Just 1 minute. Now your pointer PTR is at the second location. So it is 2, that is less than or equal to 1. the condition becomes false. The 2 is not less than 1. How 1? N minus k. The value of n minus k is 1. 2 is not less than or equal to 1, and hence here your algorithm will get completed. Because this is your fourth pass, k equal to 4. And our step is k equal to 1 to n minus 1. So this is the final output. And this is called as the manual tracing. Manual tracing means you just take the data, dummy data, and then you exercise each and every step on that data and check whether you will get the correct output or not. Yes, here we get the correct output. 1, then 2, then 4, then 5, and then 8. Clear? All of you understand? Please unmute yourself and tell me. All of you understand the concept?
Yes, ma'am.
Okay, now we see the complexity of bubble sort. Okay, the complexity of bubble sort. Complexity of bubble sort. Okay, the complexity of bubble sort is represented with f of n. F of n means the number of comparisons required to sort the given element in either ascending order or descending order. Now, I already told you that in the first pass, we require n minus 1 comparison. In the second pass, we require n minus 2, because in first pass, actually, we have the 4 comparisons, means 5 minus 1, 4. Then at second, we have the 3 comparisons. Then at, so similarly, then plus n minus 1 plus dash 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 plus 3 plus 2 plus 1. Now, this mathematical series is replaced with the particular formula, and that formula is n minus 1 into the bracket n minus 1 into n by 2. So, n square, if you simplify, then you will get n square minus n by 2. And what is the highest exponential order? 2. And the rest 2. So, the complexity of bubble sort is order of n square. Okay. And most of the time the question is asked on this topic is, what is the complexity of bubble sort? The complexity of bubble sort is order of n square. And now you compare all the previous 3 algorithms for their complexities. Initially, we discussed about the selection sort. For the selection sort, the complexity of algorithm is, for the selection sort, the complexity of algorithm is order of n square. Then the second technique is insertion sort. So in that insertion sort, again the complexity is order of n square. And today we learn the third sorting technique, and that is the bubble sort. The complexity of bubble sort is again the same, and that is order of n square. So comparatively, you do the study for all these 3 algorithms: selection sort, insertion sort, bubble sort. So all these 3 algorithms have the complexity order of n square. Okay. So this is about the bubble sort. The only 3 techniques are remaining: quick sort, tree sort, and merge sort. We will continue the quick sort in the next lecture. And we stop here.